First of all, uh, welcome back to my channel after a long time. Today we will use YOLOv12 on custom datasets. So in this custom datasets we need our own images, such like in my case we will use in this video SAR images, which is a satellite images to detect the shapes on the image. So first of all we will begin with images, and then I have already annotated. If you don't know how to annotate the images, so you have to go through my previous video list and find out how to annotate the image, and then we will do train a model. And after once we train our model, we will go for the next step to test on our image how our model is work. So this is how yellow model are work. So first of all, you have to I'm using pycharm. If you are using pycharm, so this video is for you. So okay, so this is the pycharm. You have to go and open your pycharm and go to find out your source folder. So my source folder is here, and this source folder, what you have to do, you have to go here and just click on the terminal. After the terminal, you come to here to Google and write down here YOLOv12 and click on it. Once you have opened, you will see these different link. We have to click on the first one. After this, you will see the yellow model. After yellow model, just click copy this link and go to here, but you have to like how you have to go to your source folder. Like in my case, my folder is here in YOLOv12. If you go back, you just click here CD and double dot and enter. They will go back. And if you want to go next, so then click CD, write down CD, and then next write down here the folder name which is in your computer. After that you hit enter, then you will come to that folder, and then write down here the get clone and enter the link which we copy from YOLOv12 model from Google, and get enter. It will be download. Once you download, it will be in your computer, which will be like this. So this is how we can see here. You will at the beginning you will have no run, and this is my data sets which I have to show you here. First you create the datasets folder, and that inside what is the object name, just write down the object name. In my case which is shapes, so I write down here shapes, and then we have here train and whale. But for this video I just have some few images. If you want to do a good and better results, you have more images and use some other techniques to increase your data set. So this is how we can do in deep learning or any other detection model to increase the data sets. So but this is just a video, so I use few images. So this is my images and images. This is the SAR images. We can see here. We can see here. This is the image, and this is the shapes on the image. Okay, and then here we have a label. Keep in mind one thing. If you add like for example, if once you run your train your model and it is not a good accuracy, and you want to add more images, so just delete this label. And also here from this you can delete it. Okay, and then you run again. If you didn't delete this and run again, I think it will not work, so better to delete this. Okay, so and this is my well. We see here images, and labels. Okay, so what you have to do, just go here and come to your environment where you and source folder where you are working. I'm working in this section. Okay, so this is my source folder. So what you have to do, just first of all, you have already done with your data sets and download, you already clone the yellow deposit, yellow you already clone yellow model to your computer. So all these will be available in your source folder. Okay, so what kind of library you need to do, there is a one folder which we call which we can say requirements. So this requirements and the one requirements which we already download in the, I have already changed it and I will provide you this. You can just update according to this. So then you have to pip install minus or a minus requirement. It's okay if you want to create a new folder which is you want to give a name is minus requirement. It's also okay if you keep it the same and just use this and your yellow and your requirements, just hit enter and run it. Okay, they have a no problem. Okay, so this is we have done with this library. And if you run the code and you face some problem sometime, like this library now, for example numpy is missing, blah blah is missing, so what you have to do, you just write down here pip install and write down the library name and hit enter. It will automatically install. So what you have to do, if you are using GPU, so for that you need to do this. Let me I just write down this for this video to directly check the GPU is available or not. So if you're using a GPU, so you have to check you have to use this if it is installed. Okay, if not, you need to install. So click here, they will give you a message a true. If it is true, if they are available, they will give you a message is true. So in my case it is available. If not, here will be false and it can show 0. Okay, so in my case GPU is available. So after that, what you have to do, you need to train your model. You just need to write this from ultralytics import yellow and the main model which we downloaded, which is a small model, and this is the model specification. We use in this model 100 epics. Image size was used 320, batch size was 8, and the name was shape detector, and device if you use CPU, CPU, you can just change this to 1. If you are using GPU, you need to use 0, and worker is 8, and just hit enter. Once you hit enter, it can be this one is showing for GPU, like when you are running, and after you done with your hit enter with this code, then I have 100 epics, so they are going with 100 epics. The results will be like this. So once you're done with this, then your model will be trained. So maybe it can take 10 minutes if you're using GPU. If you are using, in my case the images are less, so that's why they take 10 minutes, but this is GPU. If you are working with the CPU, maybe it can take hours. Okay, several hours. And what you need to do after you train your model, you have to test your model, how it can work. So I will show you here 2 images in my case. One is called 3, one is called 11. This we can say this is a complex image for a model because they have land same color with shape. This is the shapes, and this is also have some color used, you know, the color are same. If who are watching this video who are from remote sensing, so they will understand. If you are from different major, so you just ignore this. Okay, and this is a simple image. We can clearly see these are the shapes, but in this image we are not see very well each and every shapes. But this is need another video for explanation, so I will go ahead. So let me test my image 3. Just hit you need to write this code and hit enter. So let's have a look. Right now this is the image which we just hit enter and get the results by one hit enter. So this is also a shapes. This is missing because the image are less. This is also a shapes you see, and the image we label this as the shapes, but the image is very complex, so they detect some miss and false detection. Right now I will change this to image 11 so we can have a look with the image 11. Let's have a look. Very soon the result will be come out. So we can see here each and every shapes is all here small and big size shapes. They you see they here they show 1 2 3. They detected 3 shapes, but actually it is one shapes. And also this is also we label a shapes. This is also this also this also, but there is a missing shapes. We need have we all are familiar with YOLO model. They need a lot of data, but this is just for a video to understand how to detect shape and satellite image using YOLO. So this is just for learning. You can add a lot of data so you can have a better results. So this is how we detect image through by YOLO using satellite image or any image. For a computer vision we can use any image and any video to detect. So this is all about YOLOv12 shape detection. So thank you so much for watching this video. See you in the next video. Bye bye.